Word, and let's see. So let's start with this problem here. So again, the idea is we're simplifying this problem. And so the first thing I'm going to do is I notice that I have a negative and another negative. So a negative divided by negative is a positive. So I'm just going to write it. I'm going to rewrite the problem like this. Okay, and then the next thing I can do is I can say, look, 16 and 24. We can divide both of those numbers by 8. So 8 goes into 16 2 times, and 8 goes into 24 3 times. And then I have x to the 7th and x to the 8th. So now the last part is I'm going to leave the 2 and the 3 alone, and then we're going to deal with our x's. So usually the way I present this part here is I ask ourselves, okay, so where do I have more x's? Do I have more x's on the top or more x's on the bottom? And so since I have more x's on the bottom, what I'm going to do is I'm going to subtract my powers. So I'm going to take 8, and I'm going to subtract 7. And whatever power I end up with, that's going to tell me how many x's I'm left with on the bottom because there's more on the bottom. So 8 minus 7 is 1. So there's 1x on the bottom. And so I just have 1x there, down there. And then we're done. So anytime I'm sorry, go ahead.
I'm sorry. That was the perfect explanation, but I messed up. It was actually the one right above that one.
Okay, let's do that one. So let me scroll back this way. Here we go. Okay, so same thing here. So the first thing I'm going to do when I'm looking at this problem is I'm going to say, well, look, we can divide them both, or 4 goes into 12 3 times, and because it's negative, I'm going to keep a negative there. And then the next thing I'm going to do is I'm going to look at my powers again. So both of them are y's. So I'm going to ask myself, where do I have more y's? Do I have more y's on the top, or do I have more y's on the bottom? We're going to say, well, we have more y's on the top. So whatever power we're going to end up with is going to be upstairs because there's more of them on the top than there is on the bottom. And so 8 minus 3 is going to leave me with a total of 5. And so our answer is just negative 3, y to the 5th. We're not really left with anything on the bottom. We could say we're left with the number. We could say we're left with the number 1, but remember, when you're left with a 1 on the bottom, you can just write it as a whole number.
Ah, okay, it was the one that was messing me up. Thank you. I totally forgot that you can remove that one.
Yeah, good deal, good deal. Okay, so let me keep going here. So I'll tell you what, I'm gonna do the same thing with this one. And so we're gonna keep playing that game where we're looking at our powers. So first off, with the number 5, there's nothing I can do with that 5. There's nothing for me to reduce with it, so I'll just leave it where it is. And then we'll start with the powers, and let's start with the a's. So the question I'll ask myself is, where do I have more a's, on the top or on the bottom? And we're going to say we have more on the top. So we have 3 on the top, and even though I don't see it, we really have 1 on the bottom. So 3 minus 1 is 2, so there's 2 a's on the top. And then I'm going to do the same thing with the b's. So I'm going to ask myself, where do I have more b's, on the top or on the bottom? And we're going to say, well, there's more on the bottom. And 6 minus 2 is going to leave me with 4. And so then we're done with that one.
I'm sorry, why was the A on the bottom removed again?
So let's see. Let's come back here. Let me just clean this up. Yeah, so are we good with the 5 that I didn't do anything with it because there was nowhere really to put it?
Yes.
Okay. So if I look at my a's, even though I don't see the power there, the power is understood to be 1 because there's just 1 a, right? So then when I look at my a's, there's 3 on the top and there's 1 on the bottom. So when I subtract my powers, 3 minus 1 is going to leave me with 2, right? And then for the b's, 6 minus 2 is going to leave me with 4.
Oh, okay, thank you.
Alrighty, so let's take a look at the next one here. So we have negative 3x squared y to the 5th over 12x to the 6th y to the 8th. Okay, so we're going to go about this the same way. So first thing is 3 and 12. I can divide them, both by 3. So 3 goes into 3 once, and because there's a negative, I'm going to put a negative 1 there. And 3 goes into 12 4 times. And then now we're going to take a look at our x's. So there's 2 x's on the top, and there's 6 x's on the bottom. So there's more x's on the bottom than there are on the top. So now when I subtract 6 minus 2, it's going to leave me with 4. And then we'll do the same thing for the y's. There's more y's on the bottom than there are on the top. So whatever number of y's I have left, they'll be on the bottom because there was more on the bottom to begin with. And so 8 minus 5 is going to leave us with a total of 3. And so our answer is just -1 over 4x to the 4th, y to the 3rd. And so anytime I'm doing this division idea, I'm really just subtracting my exponents. I'm subtracting my powers, and wherever there's more of them, that's where they're going to stay. So if there's more on the top, they'll stay on the top. And if there's more on the bottom, then they're going to stay on the bottom. Okay, so let's see. Okay, so let's see. The next part here says the quotient rule, part 3. It just says that if we have the same number on the top and the same number on the bottom, then those parts are going to cancel out to being 1. Okay, so let me explain what I mean by that here. So I'm looking at this problem. I'm going to do the same thing. So we're going to say, look, let's reduce the 5 and the 10. So 5 goes into 5 once and into 10 2 times. And then we're going to say, okay, well, what about the b's? Where do I have more b's? Well, I have exactly 2 on the top and exactly 2 on the bottom. So because they're the same, those b's just cancel each other out. Okay. And then with the c's, there's more c's on the bottom than there are on the top. And again, there's 3 on the bottom and there's 1 on the top. So 3 minus 1 is going to leave me with 2. Right? And again, one way I could kind of think about this, and this is like really breaking it down, but I hope that the way I explained it makes more sense. But one way I could do this is I could say, look, there's 5. B squared means that there's 2 of them. And there's a C, and then there's a 10, and B squared means there's 2 of those, and C to the 3rd means that there's 1, 2, 3. So the 5 and the 10 reduce to 1 over 2, right? And then this B cancels with that one, this B cancels with that one, and this C here cancels with one of them over there, but I'm still left with those 2. And so that's how we end up with 1 over C squared, right? And so that's kind of like the long way of breaking it down, but it's a good way because it's visual, we can see it. Now, the only thing is if you have like, you know, C to the 23rd power on the bottom and C to the 18th power on the top, you don't want to have to write out, you know, 18 C's or 23 C's or anything like that. You're just really doing the subtraction. Okay. All right. And so for the next one here, we're going to go about it the same way. So first thing I'm going to do is I'm going to say, okay, can I reduce 18 and 24? And we can actually divide them both by 6. So 6 goes into 18 3 times, and 6 goes into 24 4 times. And then now we're going to look at our A's. So if I look at my A's here, let's come back, here we go. A to the 6th, A to the 5th. There's more A's on the top than there are on the bottom, and there's only one more A, so I'm going to leave that A on the top. My B's, we have exactly 3 on the top and the 3 on the bottom, so those B's are going to cancel out. And then for this C to the power 0, so there's a rule that says anything to the power 0 is just going to leave us with 1. So any number to the power 0 other than 0, but if it's x to the 0, 5 to the 0, -8 to the 0, it's always going to be equal to 1. So right here, I'm going to put a little dot with a 1. But I want you to remember, what happens when I multiply by 1? Well, everything kind of stays the same. So if I see anything with a power of 0, I can just kind of scratch that one out too. That's what we call the 0 exponent rule. All right. So the next one here talks about something called raising a power to a power. And it says when we're raising a power to power, we keep the same base and we multiply the exponents. So in this problem here, I'm going to keep the W, but we're going to multiply the powers together. And 5 times 8 is just going to give us 40. And so for this next one here, the first thing I really need to understand is that there's two parts. There's an A and there's a B. And so I know the power of the B here is a 3, and because it has a 4, that's going to give me a B to the 12. But again, even though I don't see it, the number on the power of that A really is a 1. And so again, when I multiply my exponents, 1 times 4 is going to leave me with 4. So my answer is really going to be A to the 4th and B to the 12th. Okay. And so I'm going to do the same thing here, and I'm going to work my way actually from the C's coming back to the B's and the A's and then the 3. So again, because I don't see it, I know the power on the C is a 1. So 3 times 1 is just 3. And 3 times 2 is 6. And 3 times 3 is 9. And then remember what we said about the power on the 3. If it's not there, it's understood to be a 1. So this is now a 3 to the 3rd. Okay. So then what I have to remember now is, well, what does 3 to the 3rd mean? 3 to the 3rd means 3 times 3 times 3. So 3 times 3 is 9 times 3, and 9 times 3 is 27. So this is really going to give me 27, A to the power 9, B to the power 6, and C to the power 3. So when I have a number that's being raised to a power, I got to make sure that I actually write it out like this and then kind of figure out what that number is going to be. Okay, so let's see. I heard something in the chat. Let's take a look. Good, good, good. I'm glad it's working. Excellent. Okay. All right, so let's do the same thing here with this one. And so the first thing I'm going to do, again, I'm going to distribute my powers. So I'm going to have n to the power 10 and m to the power 15, because again, we're still multiplying our exponents. All right. And then here, I'm going to have a to the power 20. Now, I want you to notice this is not just a 2, it's really a negative 2. So I'm going to write like this, negative 2 to the 4th power. So again, I want to remind myself, what does that mean? What is negative 2 to the 4th power? So negative 2 to the 4th power means I'm going to write down the number negative 2, and I'm going to write it down 4 times. So now I know that when I multiply negative 2 times negative 2, that gives me a positive 4. And that negative 2 times that negative 2 also gives me a positive 4. But 4 times 4, when I multiply, it gives me 16. So this is really going to be 16 a to the power 20, right? And again, the reason I have to do that is the number on the inside of my parentheses was a negative 2, so I got to make sure that I write that negative 2 out as many times as my exponent tells me, right? Okay, so this one, I'm going to do it very much the same way. And so I'm going to raise my powers. So the first thing we're going to do here, we're going to say, okay, 5 times 5. Well, I know that's going to give me 25. Okay, now again, the power of my x here really is a 1. So 1 times 5 is still going to be 5. And then I'm going to figure out, well, what does 6 to the 5th power mean? So let me do this part over here on the side. So 6 to the 5th power means I'm going to write down the number 6. I'm going to write it down 5 times, right? And so I'm actually going to show you this part here on the calculator so we can see how we're going to do it. So let's go to calculator. Here we go. Okay. And so let's see. Let me stop sharing this. And then let me come back to my calculator. So we had something like 6 times 6. We're going to do it 5 times. So my calculator is going to go like this. Let's see. 2, 3, 4, 5, and then hit equals. So I'm coming up with 7,776. That's what I'm coming up with. So I'm going to stop sharing this part here. And let me come back to my notes. Here we go. And so we end up with p to the 25 over 7776 x to the 5th. Okay. And so, guys, as you're doing these problems here, if you end up with a really big number, don't get too nervous about it. Okay. You know, the nice thing about using the MyLab software is that for every homework problem, you know, you kind of get like 3 shots before you either get the problem wrong or you can hit similar questions. So, you know, if you enter in a number and you're uncertain about it, you know, you hit the little check your answer thing, and if it tells you you're wrong, it's okay. You know, you still got 2 other shots, right? All right. So let's go ahead and do this next one. So again, I'm going to go ahead and deal with my variables first. I'm going to deal with the letters first. So 1 times 2 is going to be x squared. 2 times 2 is going to give me 4. And then, guys, remember, we're squaring our numbers here, right? So since we're squaring a number, 5 squared means 5 times 5. That's just 25. And 7 squared is 7 times 7. That's just 49. Just be careful that when you're doing this here, guys, that you remember you are actually squaring your numbers and not multiplying them by 2. So sometimes people want to write like 10 over 14, but you're not multiplying 5 times 2. You're multiplying 5 times 5. And the same thing with the 7, right? You're not doing 7 times 2. You're doing 7 times 7. So just be careful with that. It's a common mistake people make. And, you know, you make it once, that's fine. But you want to just make sure you catch it, okay? Okay, cool. So that was 4.1. So we definitely got time to go through 4.2. And so 4.2 deals with these things called negative exponents and scientific notation. And so we'll deal with negative exponents first. Okay, so negative exponents says if I have a number and it's being raised to a power, so I'm going to write it here. Like if I have a number raised to a power, I'm going to think about this as a fraction. And I can think about it as a fraction by writing it over 1. If we want to change that to a problem that doesn't have a negative exponent, what we do is we flip the fraction. The 1 goes to the top, the part where the exponent comes to the bottom, and it now becomes positive, okay? So this is how we write our problems with positive exponents, okay? And so for the first one here, so again, the first thing I'm going to do, I'm going to pretend this is a fraction by thinking about it over 1, and I'm just going to flip it. And when we flip it, our exponent becomes positive. And that's really all we need to do for these. So the same thing happens for the next one. I'm going to think about this as a fraction by writing it over 1, and I'm going to flip it, and my exponent becomes positive. Okay? All right. So this next part here says, well, what do I do if the exponent is negative, but instead of being at the top of the fraction, it's at the bottom? Okay, so let me write it here. So if I have something like this, x to the power negative n, I'm going to do the same thing, y'all. I'm going to write it as a fraction, and when we flip it, the exponent comes to the top, and it becomes positive. And the same thing happens if I have a fraction where there's negatives in both places. If it's on the top or if it's on the bottom, I can flip that fraction. Oops. I can flip this fraction, and the exponent from the bottom is going to move to the top. It'll be positive. And the one that on the top, if it was negative, it can move to the bottom, and it'll also become positive. Okay. So let me show you what I mean by that. And it's going to work. Okay, so here we go. First thing I notice, I have a negative exponent down here on the bottom. So I'm going to flip my fraction. I'm going to write it as y to the 8th over 1. Now, the only thing that I'm going to do here is because my denominator is a 1, then we can just go ahead and drop it and just write it as y to the 8th, okay? Because we don't necessarily need to write it over 1, right? So like if I was telling you, what's 7 divided by 1? Oh, it's just 7. What's 5 divided by 1? Oh, it's just 5. So y to the 8th over 1, it's just y to the 8th, okay? Now, the only thing that we're moving, guys, is we're moving negative exponents because we're trying to make them positive. So I want you to notice it says write our answer with positive exponents, okay? So when I come to this next one here, I notice the first thing I notice is everything is negative. So what we're going to do, we're going to flip the entire problem. The z to the 5th is going to come upstairs. It's going to be positive. The x to the 6th and the y squared are going to move to the bottom, and now they're also positive. So again, all we're doing is we're taking the reciprocal. We're flipping that fraction. Okay. All right. So now, if you notice this one, there's parts that are negative, there's some parts that are not. So I'm going to walk you through the process and how we're going to do this one. Just like we did a little while ago. Remember what we said we were going to do? If we have powers raised to powers, then we multiply them. Okay. So the first thing I'm going to do with my variable part. So -3 times another -3 is a positive 9. And then -3 times a positive 1 is a -3. Since I'm trying to write my answer so that it has positive exponents only, this guy here is not going to move. It's going to stay, it's going to stay where it is because the exponent is already positive. The one that's going to move is this one over here. It's negative, and I can think about this over 1. It's negative on the top. So when I bring it down to the bottom, it'll now become positive. And then the last thing we're going to do is 2 to the 3rd means 2 times 2 times 2, which is just 8. Okay. So again, the one thing I need to keep in mind, I'm only moving those that are negative. If they're positive, they're going to stay where they are. Okay. All right. So when I look at this one here, the only piece that's negative is that one. So I'm going to think of this as being over 1. So the 5 is positive. It's going to stay on the top. This guy here is going to come to the bottom, and it's going to become a positive y to the 7th. Okay. Same thing here. I'm going to think about this as over 1. This one here is already positive. So I'm going to leave it where they are. But these two are both negative, so they're going to come to the bottom. And that's going to be an x to the 5 and a y to the 2. So far, do we feel okay about dealing with negative exponents? Are they making sense so far? Yeah, good, excellent, perfect. Okay, so then I'll tell you what, let's go over scientific notation. So scientific notation is a way that we can write numbers that are really, really, really big or numbers that are really, really, really small. And we call it scientific notation because usually you're going to use scientific notation if you take a science course. So we talk about, like, how far is it from here to Pluto, or how far is it from here to one of Jupiter's moons? It's going to be really, really, really far, right? So we write numbers like that in scientific notation, or if we're talking about, like, maybe in a biology class, right? And you have something like this, and we call this guy here the cell, and in the middle we have something here called the nucleus, right? And if we wanted to know how far or how wide is the nucleus, that's got to be a pretty small number. And so this is when we use scientific notation, okay? So it says, a positive number is written in scientific notation if it's in the form, and it gives me this format right here. Okay, so what this part means is that the number that's going to be here in front, think about it in terms of money. It has to be it has to be $1 or more, but less than $10, okay? So what I want to do here with this number, excuse me, and I'm going to show you how I'm going to write it in scientific notation. Even though I don't see it, y'all, there is a decimal at the very, very end. And so what I want to do is I want to move my decimal to the left. And I want to stop when I place my decimal, that the number that I have is $1 or more, but less than 10. So if I were to move my decimal and I were to put it right between the 5 and the 7, would you all agree with me that that number is going to be $1 or more, but it's less than 10? Because if I move my decimal from here and I moved it that way and I put it right there between the 1 and the 5, that gives me $1.57. So that's $1 or more, but it's still less than 10, right? And the reason why I'm putting it there is I want y'all to think about that for a minute. If I put it right here, that would be like a little bit more than 15 cents. And if I put it right here, that would be $15.70. And it has to be $1 or more, but it has to be smaller than 10. And that's why these here wouldn't work, right? Okay. Now the next part we do is we're going to take this and we're going to multiply it by a power of 10. And the power is going to be how many spaces did I move my decimal point? So look where it used to be. It used to be right here. So if I go like that, that's moving at 3 spaces. That's moving at another 3, which is a total of 6, and then 7 and 8. So my answer would be 1.57 times 10 to the 8th. Okay. Now, I'm going to do the same thing for the next problem here. So I'm going to write this as a number in scientific notation, and it's 78,200. So again, the first thing I need to figure out is where am I going to put my decimal? Well, if you can tell, it's going to have to be right there between the 7 and, and the 8. Okay. And then the next thing I got to figure out is how many spaces did I move my decimal point? So remember, the decimal used to be at the end, right? So that's 3, and that's 1 more, that's 4. And so I'm going to put a couple more problems here because I think I'm missing something, and I want to make sure that I get to show you all of them. And I know I did in the YouTube video, but I just may not have done it here in your notes. But I want y'all to notice something. These numbers here are what we call big numbers, right? Like this number is 78,200. So if somebody says, hey, I got a job for you, it's going to pay 78,200 every year. Do you want it? You're probably going to say, yeah, sign me up. Or if you decided to play the lottery and you won $157 million, you'd probably be a pretty happy person too. So anytime my numbers are big, my exponents here, my powers, are going to be positive numbers, okay? So now I'm going to show you, before I go on to the next two, I'm going to show you what happens if my numbers are small, okay? So let me erase this part over here. Let's get rid of this. So, all right. So I'm going to show you two other problems. And we're going to figure out how to write these in scientific. Okay, so the first thing I'm going to do, I'm going to write down my numbers so that the first number I have is a number that's more than $1, but less than 10. So I'm going to have to move my decimal place, but I'm going to move it now to the right. So if I move it to the right and I put it right here between the 3 and the 7, I would end up with 3.7. That's more than $1, but it's less than 10, okay? And we're going to do the same thing we did before. We're going to count how many times did I move my decimal place. So look where it used to be. It used to be right here. Now if I count 1, 2, 3, 4, 5, 6, we moved it 6 spaces. Okay. But I want you to notice something about this number. This number here is small. 0.000037. That's not even a penny. That's like if you took a penny and you knocked off a little smudge of it. That's how much money, that's how much that penny, that little smudge of a penny would be valuable, right? That's would be the value of it. Anytime I'm dealing with small numbers, my exponents are now going to be negative, okay? So I'm going to do the same thing here for this next problem. I'm going to move my decimal place to the right so that I end up with a number that's more than $1 but less than 10. So what about 4.29 times 10? Now I'm going to figure out how many spaces did I move it. 1, 2, and again, because my number is small, it's going to be a negative 2, right? So this helps me figure out when my number is big, my exponent is going to be positive, right? Excuse me. And then when my number is small, my number is going to be negative. My exponent is going to be negative. Okay. So I'll tell you what, let's take a look at these here. And so these problems are now just asking us to go backwards, meaning can we write this as a regular number? And we definitely can. So the first thing I want you to notice about this number here, it's 8.137 times 10 to the 7th. So my question to y'all before we do this problem is, would you all say this number is big or would you all say this number is small? Anybody know? Would this number be big or small? Big, yes, definitely. It's going to be a big number because our exponent is positive, right? Excellent, perfect. Okay, so since this number is big, what that means I'm going to do, I'm going to take my decimal point, and it's going to move 7 spaces to the right. Okay. So I want you to notice what I'm going to do. I'm going to write 8.137, and I'm going to show you what I think is the easy breezy cover go way of figuring out, well, how many zeros do I need to put down? So remember what we're going to do. We're going to move it a total of 7 spaces, right? We're going to move a total of 7. If you notice, I already have 3 numbers right there, and I need to go a total of 7. So if there's already 3 numbers right there, to get to 7, that means I need to add 1, 2, 3, 4 zeros, and here's my number. And that would be 81,370,000, right? Okay, perfect. And then if I look at the next one, it's 5.36 times 10 to the negative 2. So first thing I want you to notice is because my exponent is negative, that's telling me that this number here, y'all, is going to be small. So my decimal point is going to move 2 spaces to the left, right? So I'm going to put a point, and I want you to notice how many numbers do I already have in front of my decimal. I already have 1 number, and then if I need to get 2, that means I just got to add 1 0, and so there's my number again in decimal form, right? And I'll tell you what, we'll do the same thing here. My exponent here is going to be small because my exponent is negative. So I'm going to move it 4 spaces to the left, right? So since I'm going to move 4 spaces to the left, and I already have 1 number right there, that tells me I just need to write the number 0 3 times, and my answer is 0.0047. And I'll tell you what, we're going to do one more. So let me write something here. Oh, let's see. We'll make it easy breezy cover girl. Come on, pen. Okay. Oops. 5.23 times 10. Oh, I don't know. We'll keep it easy to the 4th. Okay, so if anybody has an idea of how you would write this, anybody want to put it in the chat? 5.23 times 10 to the 4th. What number would you come up with? Anybody know? Okay, so let's come back and look at the problem, guys. So remember, if this is a power of a positive 4, this means that my number is going to be big, right? So I'm going to move my decimal 4 spaces that way. So if you notice, I already have 2 numbers right here. That just means I need to add another 2 more zeros. And so the number we end up with is 52,300. Okay. So again, really all you're doing here, y'all, for scientific notation is just if you have a number in regular form, which we call decimal notation. Okay, we got a number in regular form in decimal notation. Can you write it in scientific, or if your number's in scientific notation, can you go back and write it in the regular format? Okay, that's pretty much what that is. Okay, so I'll tell you what, let's do a little bit of 4.3, and we can at least get to the introduction part to it. And so 4.3 is fundamental polynomial operations. And we have something called multivariable polynomials, which is when we have more than one variable, right? So this is what a polynomial looks like, guys. Okay, polynomials, all the exponents, the powers here are all going to be whole numbers. So my powers. Whole numbers like 0, 1, 2, 3, so on and so forth. So my exponents are not going to have fractions. They're not going to have negative numbers. Okay, they're all going to be 0, 1, 2, 3, 4, 5, so forth. Multivariable polynomials is a polynomial with more than one variable, and these are what we call multivariable polynomials. So if you look, there's an xy. Here's another xy, there's an x squared and a y squared, and then there's an x to the 3rd and a y to the 9th over here. That's what we call multivariable polynomials. And then we have something called the degree of the term. And the degree of the term says it's the sum of the exponents. So sum just means we're going to add them up. And so if we have only one variable, it's just whatever the power is. If we have 2 variables, what we're going to do is we're going to add the exponents on each of those, 1 and 1, and that's how we come up with 2. And like if I look at this one here, if I add my exponents together, 4 and 2 is going to give me 6. Okay. And then the degree of the polynomial is the highest degree of all the terms in the polynomial. So what we mean by that is if I look at this polynomial here, the highest power was 3, so the degree of that polynomial is 3. And then if I look at this one here, I say, okay, well, what's the degree of both of them? Well, there's one x and one y, so that one has a degree of 2. There's an x squared and a y, so 2 and 1 gives me 3. And then there's 1x and 3y, so 1 and 3 gives me 4. So the degree is 4. It's the highest one, okay? And then the last part, guys, we have something called monomials, binomials, and trinomials, okay? So the first part here says, state the degree of the polynomial and whether it's a monomial, binomial, or trinomial. So the first thing we're going to do, we're going to find the degree of each of these polynomials. And then we'll answer the next part. Excuse me. Oh, come on, Tim. Okay, so the degree, I'm going to take these exponents because there's 2 letters. I'm going to add them up. That's going to give me 5. The degree of this one is the highest power. That's 3. And the degree of this one here, so 4 and 1 is going to give me 5. And 5 and 2 is going to give me 7. So the degree here is 7. Okay. Now, monomial means that there is one term. Come on. Binomial means there's 2 terms. And trinomial means there's 3 terms. Oops. Okay. So when I look at my problems here, come back here, There's one piece, so this is a monomial. There's 1, 2, 3 pieces. So this is a trinomial. And then there's 1 and 2 pieces. So this is also a binomial. Okay. So a monomial just means one piece, trinomial is 2, trinomial is 3, and binomial is 2, okay? All right, so the next part here, y'all, is adding polynomials. Adding polynomials is the same thing as combining like terms, okay? So we're going to go ahead and combine a negative 2x and a positive 5x to leave us with a 3x, and then a plus 19 and a minus 6 is a plus 13. And I'll do the same thing here for this next one. So a positive x squared and a negative x squared are going to cancel each other out. A minus 4x and another minus x. So if I owe you $4 and I borrow one more, now I owe you 5. And then a negative 8 and a positive 1. So if I owe you $8 and I give you 1, now I owe you 7. And then for this one, guys, remember, I'm combining like terms. So there's no other x to the thirds other than that one. So I'm just going to write that down, negative 4.6 x to the 3. And there's no other x squareds other than this one, so I'm going to write down plus 9.8 x to the 2. And then I'm going to go ahead and combine these two. So 5.6 and 4.5 are going to leave me with, I'm just going to add those together. Let me get my calculator real quick. Let's see. Oops, where is it? Here we go. 5.6 plus 4.8 is 10.4. And then a minus 0.3 and a minus 1.7 is just a minus 2. So if I owed you 30 cents and I borrowed another $1.70, now I'm going to owe you $2. Okay. Let's see. Oh, I forgot the x right here. Sorry about that. Okay, so now the next parts here are subtracting. Subtracting is just like adding the polynomials with the exception of one small thing. Everywhere I have that minus sign, I'm going to change it to a minus 1 every single time. Okay? So this first part, I'm just going to rewrite it. 5x minus 5. What we're going to do with this minus 1, y'all, is we're going to distribute it to both pieces. That's going to leave me with a minus 6x, and minus 1 times minus 3 is a plus 3. Now I can go ahead and worry about combining my like terms. So 5x minus 6x is a minus x, and then a minus 5 and a plus 3 is a minus 2. Okay. So I'll do the same thing for the next one. I'm just going to leave the first piece alone, so I'm going to write it as 2x to the third minus x squared plus 5. And I'm going to go 1, 2, 3, and 4. So this is a negative 6x to the third. A negative 1 times a positive x squared is a minus x squared. A minus 1 times a minus x is a plus x. And then a minus 1 times a positive 1 is another minus 1. And now we can worry about combining our like terms. Okay. So 2x squared minus 6x squared, I'm sorry, x to the third is a minus 4x to the third. And then a minus x squared and another minus x squared is a minus 2x squared. And then we just got this 1 plus x by its lonesome, so we'll write them down over here. And then finally a plus 5 and a minus 1 is just a plus 4. Okay. All right. So let's try the same thing for this next problem here. again, I'm going to leave the first one alone. So 1.3 x to the fourth minus 3.1 x to the third plus 6.3 with an x. And then we'll distribute that. So a minus x to the fourth. This is going to be a plus 5.2 x squared. And then this one here is going to be a minus 6.5 with an x. Okay. And so now I'm going to worry about combining my like terms. So 1.3x to the fourth, I can think about that as a minus 1x to the fourth, will leave me with a 0.3x to the power 4. Okay. This is the only x to the third that I have, so I'm just going to write it down. And this is the only x squared that I have, so I'm going to write that one down. And then finally, right here, we have a plus 6.3x and a minus 6.5x, which is going to leave me with a minus 0.02x. And so those are those parts. And then, so for the next one here, it says perform the operations indicated. So as I'm going through this problem here, the first thing I'm going to do, I'm going to worry about at least adding these two together. So 8x plus another x is going to leave me with a 9x. And then a plus 2 and a minus 7 is going to leave me with a minus 5. Okay. And then just like we did before, I have this negative 1 right here. So I'm going to distribute that negative 1 to both pieces. So that's going to leave me with a negative 3x and a minus 1. Okay. And then I can combine my terms. 9x minus 3x is a 6x. And a minus 5 and a minus 1 is a minus 6. Okay. All right. So let's go ahead and do the same thing for the next problem. I'm still combining my like terms. So 12x squared y and minus 2x squared y. Those are my like terms. So 12 minus 2 is 10 x squared y. And then, let's see, we have a minus xy squared and a plus 5xy squared. So I can think about this as a negative 1 and positive 5 is a positive 4 xy squared. And then finally, a positive 5 and a negative 8 is just a minus 3. Okay. All right. And so I'll tell you what, guys, I'm going to hold off on this one here because I want to make sure that I get to the next one. Because this problem here is, it's more of a word problem, and sometimes these can be a little tricky. So it says, prisons. The number of prisoners held in federal and state prisons measured in thousands can be described by the polynomial. And it gives me this expression right here. The variable x represents the number of years since 1990. And the question says, estimate the number of prisoners in 2005. Okay. So I'm trying to figure out, I want you to think about this part here. X represents the years since 1990. So that means that when x equals 0, that's the same thing as the year 1990. And when x equals 1, that's going to refer to the year 91. And when x equals 2, that's going to refer to the year 92, and so on and so forth. And what we're trying to figure out is what value of x is going to correspond to the year 2005. Would anybody know what value of x would correspond to 2005? If 0 means 1990, and if x equals 1 means 1991, And if x equals 2 means 1992, and so on and so forth. Anybody know what value of x would correspond to 2005? So let me show you how we can figure that out. So one way we can do that is we can figure out how many years have elapsed from here to here, right? So if we're to take 2005 minus 1990, 2005 minus 1990, that would give us 15. So then from here to here is also going to have to add up to 15, right? Okay. So what I'm going to do now is I'm going to come back to this problem, and everywhere I have the letter x, we're going to plug in the number 15. Okay. So guys, I'm going to show you how I'm going to do this part on my calculator. So I'm actually just going to write out a couple of things first. So on my calculator, 15 squared, I already know is the same thing as 225. And then I'm actually just going to do this part here. So I'm just taking my calculator from my phone, and I'm taking 77.82 times 15. And so this number is coming up to 1,167.3 plus 743. Okay. Now I'm going to go ahead and multiply this part out. So 2.06 times 225 is, so now I got a negative negative 463.5 plus, these are both positive, so I'm going to go ahead and add those together. 1167.3 plus 743 is 1910.3, and now I'm just going to combine these two, and I'm coming up with 1,446.8 is the number that I'm coming up with, right? So this is the number that of prisoners, and this here is in thousands, okay? So that's the number of prisoners we have in the year 2005 in thousands. And so again, I want you to think about this problem for a minute, guys. You know, there was a little bit of work that I had to do because I had to figure out, number one, what was the number that I was going to be plugging in for x, okay? So our time is about up, and I got another class that's about to start at 6, but we were able to do part of 4.1, all of 4.2, and all of 4.3. So we actually did pretty good today. So guys, I'm hoping that as we went through these problems, that you could see we were able to knock out like 2.5 sections in just under an hour. So I'm hoping that as you go through your homework, that you're finding that 4.1, 4.2, 4.3, even 4.4 and 4.5 are making some sense, okay? But definitely let me know if you guys got any questions, because you know I'm happy to help you guys out, okay? So Serena and Esmer, thank you all for showing up. I definitely appreciate it. And I will send out a copy of the video to everybody this afternoon once I'm done with my other class, all right? And in the meantime, y'all got any questions, just let me know.
All right. Thank you so much, sir. You have a good day.
All right, you do the same. Okay.